We have the following project on our right that we're going to be looking at, and we're going to be using these instructions to do so. Now I'm just going to show the instructions once, and that way we can actually work on the project without any interruption. So these are the outlined steps. This is everything that we're going to need. So to start this off, we want to look at our previous project. We're going to want to remove the random number generator from the input of our RAM and make reading its default state rather than writing. So we know we toggled between reading and writing with this. So if it's low, we're going to be writing. str is high, load is low. And then when this is high, we're going to be reading rather than writing. So we want to just hardline this or hard code this. We could leave this in, as a matter of fact. We could if we wanted to. But this is just a for sure way that it's going to be correct once it's being graded. We're also removing our random number generator. We can see when our bit 1 of the RAM goes high, we want the counter to load an input value. We'll go more into detail about this in a second, but that's kind of this business up here. We want to set the input value of our counter to a constant of 1. This is our data in constant. We set it to a value of 1 right here, like that. Now we want to leave bit 0 of the RAM output to toggle the output multiplexer, which we've done previously. You can see it's a little bit cut off right here. I've done that intentionally because that's just going to be this. So this is just printing out here. We're basically manipulating the RAM part for it. The counter we are using has the ability to load an input value when its input pins are set in a specific way. To read the description of the pins, we can highlight over it and we can figure out how it works. We can see that this is the load and this is our counter. Now, the counter's load input needs to be high and the count input needs to be low when actually loading our input value. And that's when we're doing our jump. That's our input. So this needs to be high. This is going to be low when we do a jump. You can see it kind of change once we do the actual jump right there. But when doing regular increments like how we were doing now, the counter's load pin needs to be low. So this top load pin is low, and the count pin needs to be high, which is what we have. So that's good. Finally, we want to modify the contents of our RAM. If we right click our RAM, we can actually click edit contents, and it's going to look something like this. It's going to bring this up. And we want to print out the format that we have that's given to us. And so to do that, I think the 1 toggles with a even number, and the A toggles with an odd number. So 2 is reserved, and the reason why 2 is reserved is because O2 is a jump back. O4 is a jump forward, but that's for the next assignment. With O2 jumping back, we need to jump back to the first index, which is handled with this. This gives us that input. So we're going to jump back to the first index with that. And that's really it. Our Walker decoder just got a whole lot more powerful from the previous one. It can now repeat sequences of instructions. The final submission is just going to be a zip file containing the .crc and the .text from our RAM. And that's going to be about it. Last thing is to save this. If we want to save this, we can click save. We will save it as a text file, or you can go save image, and you're going to want to save it as a text file. Mine is data.txt. But that's going to be all for this assignment.